Today we are going to work on solving logarithmic equations. I think the easiest way to do this is to just remember the definition of a logarithm. So you want to have your log expression isolated on one side of the equation, so you want constants on the other. And then you're just going to use the definition of a logarithm to simplify this. So by the definition of a logarithm, 2 to the 5th equals x. So x is equal to 2 to the 5th is 32. Okay, again, if you're not sure of that, you are checking that on your calculator. Okay, so then if we want to check this, we have log base 2 of 32 is equal to 2 raised to the 5th power. Okay, so substituting an x in the original equation, we get a true statement. So we know we got this correct. We need to remember that when we have the natural log, that's base e. Okay, so if you want to lightly pencil that in for yourself, you can do that. But this shows us that e to the 5th equals x. So this is an exact answer for us. Okay, and again, being able to differentiate between exact answers and approximate answers is going to be important. You need to pay attention to the instructions that are given. So this is our exact answer. Remember that e is a number. It's around 2.71. And so this is our exact answer. In order to find an approximate answer, we use our calculator. Okay, so we're saying raised to a power is usually the second function on your natural log. So e to the 5th is so x is approximately 148.41. Let's say we're rounding to 2 decimal points. Okay, so now if we want to check this, I want to plug into the original equation. I want to see if the natural log of 148.41, we're going to want that to be about 5. Okay, and 4.9999 repeating is about 5. So the answer, that's promising evidence that we have the correct answer. Okay, so we checked this one with a calculator. Okay, so like many of our problems, sometimes these look a little bit more complicated, but we are still using the same exact procedure. So we're using the definition of a logarithm. 2 raised to the 3rd is equal to our argument, which is 3x minus 4. And here we're just going to simplify and solve for x. So 2 to the 3rd is 8. We're going to add 4 to both sides. We get 12 equals 3x. And again, we're going to divide both sides by 3. So we get x equals 4. So let's check and see if this works and makes a true statement. So we want to see if log base 2 of 3 times 4 minus 4 equals 3. Okay, so think about this. All I'm doing is I'm putting in my x value for x. So I get log base 2 of 3 times 4 is 12, minus 4 is 8. And let's check, is 2 to the 3rd equal to 8? That's true. So I know I have the correct answer. One other thing real quick, you always want to do a check on your logs, okay? Because you can have extraneous solutions. And that's what we're going to see in our next example. So we are starting this out exactly the same, 2 to the 3rd. Okay, and that's because our base was the same and our constant on the right side was actually the same here. is going to be equal to x squared minus 7x. So now we have, just simplifying, 8 equals x squared minus 7x. I'm going to move that 8 over. I'm going to subtract 8 from both sides and get x squared minus 7x minus 8. And now I have a quadratic equation. I'm going to check to see if I can solve that by factoring. So I need two numbers that multiply to negative 8 and add to negative 7. I recognize those two numbers as x minus 8, as those two factors as x minus 8 and x plus 1. So just a real quick check. Negative 8 times 1 will be negative 8. Negative 8x plus x will give me negative 7x. So setting each of these factors equal to 0, I am going to get x equals 8 or x equals negative 1. So next I need to do my check. So I get log base 2 of, I am going to try to do some mental math here. X squared, 8 squared would be 64 minus 8, minus 7 times 8 would be minus 56. We want to see if that's equal to 3. And I am checking my x equals 8 first. So I get log base 2 of 8 equals 3. We already talked about how we know that one is true. And now we're going to check x equals negative 1. So we get log base 2 of negative 1 squared is 1. Negative 1 times negative 7 is plus 7 equals 3. So we get log base 2 of 8 equals 3. And again, we saw that's true. So this time we do have two answers. We're now moving over to the back side to look at example 3. So this time it's a little more complicated because we don't have our logarithmic expression by itself. So we want to do whatever we can to isolate the logarithmic expression. So in part A, I am going to subtract 8 from both sides. And I'm going to get 4 times the natural log of x equals negative 1. I'm going to divide both sides by 4. So I'm going to get the natural log of x equals negative 1/4. Now that I have the natural log expression by itself, I'm going to use the definition of natural log or logarithms. I remember that this has a base of e. So e to the negative 1/4 equals x. Okay, I am okay leaving an answer like this. Sometimes on a multiple choice test, you might see that this is 1 over e to the 1/4. You might also recognize that as 1 over the 4th root of e. Okay, you should be able to recognize that all three of those answers are equivalent. And then using our calculator, we also want to find our approximate value for x. So we get second e to the negative 1/4. Okay, so we get that it's about, x is about 0.79. Okay, and let's check this. 8 plus 4 times the natural log of 0.79 equal to 7. Is about, so we get I get on my calculator, I'm sorry, that it's about 7. Okay, so that checks. And we could also check the exact answer here. If we do 8 times 4 times the natural log of e to the negative 1/4, we want to see if that's equal to 7. That would be 8 plus 4. The natural log of e to the negative 1/4 would be negative 1/4. And so 4 times negative 1/4 would be negative 1. 8 plus negative 1 is 7. So we can see that the exact answer checks as well. You might notice that A and B are exactly the same and think that I did a typo. Okay, but I just want to show you there are other methods to do this as well. Again, you always want to get the natural log by itself, but say we subtracted 8 from both sides, just like we did above, and we get 4 natural log of x equals negative 1. Okay, but then say we wanted to use the power property for logarithms. So we would get the natural log of x to the 4th is equal to negative 1. Well, now we could use the definition of the natural log. So again, our base here is e. So we are saying e to the negative 1 equals x to the 4th. Now, to solve this equation, we're going to take the 4th root of both sides. And whenever we take an even root, we need to remember to do the plus or minus. Okay, so the 4th root of e to the negative 1 would be plus or minus e to the negative 1/4. So that is the two answers. X equals e to the negative 1/4 or x equals negative e to the negative 1/4. Okay, but if we go to plug this into the original equation, okay, we already saw up above that e to the negative 1/4 works. Okay, so we know that's okay. But if we put in negative e to the negative 1/4, we're going to get 8 plus 4 natural log of negative e to the negative 1/4 equals 7. If you tried to plug something like this into your calculator, you are going to find that you get domain error, okay? Because remember, we can't have a negative argument in our natural log or log. So this is an extraneous solution, okay? So even when you just get numbers, I know this seems especially funky because it has the 4th root and things, but even when you just get numbers, you need to plug in and make sure it works and you don't get a negative argument. Because if you get a negative argument, then you need to call that solution extraneous. Okay, a minute and a half, less than that, to try to get the last one. For a problem like this, I would rewrite this as the natural log of x plus 6 to the 1/2 equals 2. I'm using the power rule to do 1/2 the natural log of x plus 6. I'm multiplying both sides by 2. So I get the natural log of x plus 6 equals 4. I'm remembering that my base here is e. So e to the 4th equals x plus 6. I'm subtracting 6 from both sides, and I get e to the 4th minus 6 equals x. That is my exact answer. All right, guys, I worked a little magic because I didn't want you to have to open another video today. I just found the approximation using my calculator, and then I worked out the exact answer to check it. Okay, so pause the video, pause the screen, and you can see if you can work through this.